Today we're going to start with a do now that is a review of GEMS. Remember that GEMS tells us the order in which we solve problems. GEMS stands for grouping, exponents, multiplication or division as it comes from left to right, and addition or subtraction as it comes from left to right. So we have 15 minus 3 to the 4th power divided by 9. Is there any grouping? No. So we move on to the next one. Is there an exponent? Yes. The exponent is 3 to the 4th power. What does 3 to the 4th power mean? 3 to the 4th power actually means 3 times 3 times 3 times 3. 3 times 3 is what? 9 times 3 is what? 27 times 3 is what? And remember, you can use a calculator if you need. Now that we've figured out 3 to the 4th power, we rewrite the sentence 15 minus, what was 27 times 3? 81 divided by 9. So we've done grouping and exponents. The next thing is multiplication or division from left to right. I have subtraction and I have division. That must mean that division comes first. So we would do 15 minus, what is 81 divided by 9? Write your answer here. And then the last step is to subtract that number from 15 and put your answer here. Next question. 6 times 5 minus 3 squared. Is there any grouping? No. Is there any exponents? Yes. So we will rewrite the sentence 6 times 5 minus, what is 3 squared? 3 squared is 3 times 3. What is 3 times 3? 3 times 3 is 9. We've done the exponents. Now we're looking for multiplication or division, whichever one comes first. Looks like we have multiplication. What is 6 times 5? Put your answer here, and then all that's left is to subtract 9 from it and put your answer here. Last one. We have grouping in this one. We have grouping here. But inside that grouping, we have addition and exponents. Which one should come first? Let's see. Exponents should come first because exponents is always before multiplication or division and always before addition or subtraction. So inside the parentheses, we're going to rewrite 9 plus. But instead of 2 to the 3rd power, we're going to figure out what 2 times 2 times 2 is. Let's see, 2 times 2 is 4. 4 times 2 is 8. So that's what we're going to put in here. And then we have the rest of our sentence. So now we have 9 plus 8 times 4. If we go up here, are we done with our grouping? No, so we can't move on. We have to finish what's in our grouping. 9 plus 8 gives me what? Put it right here. Then all that's left is to multiply that number times 4 and put your answer here for me. Excellent job. Now on to the guided instruction. Example number 1. The attendance this week at a museum more than, let's put a box around that, that seems important, more than tripled. Let's put a circle around that. Not that it matters which one is which, but those seem like pretty important things. More than tripled the attendance of last week. Last week, 186 people went to the museum. So more than tripled 186. We want to write an inequality to show the possibilities for the number of people at the museum. So we know that we started out with 186 well, actually, let me back up on that. We are starting with an unknown value, which we will call x, which is we want to know the number of people at the museum now, right? And we know that the number of people now is more than, so how would we write that? More than, greater than, greater than. So the number of people is greater than triple the number of people last week. And we know that the number of people last week was 186. So triple means what? Triple means times, but what times? It's also a number. Triple means 3 times the number of people last week, which was 186. So 3 times 186. Well, we can simplify that, right? Because we know what 3 times 186 is, or at least we can figure it out. Let's check. Let's see, 186 times 3 gives me what? 558. So x must be greater than 558. Now what we want to do is we want to graph the solution, because that will give us an idea of what kinds of numbers would satisfy that, meaning what could x be. So we will put some lines here. And you always want to put at least 3 lines. So we want to put our number on the middle line, 558. 558. So this is 559. What do you think goes before it? 557, right? Okay. Could x be 558? No, it can't. So we're going to circle 558 because that number is important, but we're going to leave that circle open so that people don't think 558 could be the answer, because we know that the number of people that are there now are greater than 558. So which numbers are greater than 558? Is 557 greater than 558? No, then we don't want to go that way. What we want to do is we want to go this way, and all the numbers on the number line that are higher than 558 could be an answer to our inequality. And what I want you to notice is I want you to notice the direction of my arrow and the direction of my sign. Notice that? Excellent. Let's try another one. Ben must read a minimum of 140 pages over the next 7 days. So 140 seems pretty good. We want to underline that. Over the next 7 days. Write an inequality to represent the number of pages that Ben must read each day. So if he needs to read a minimum of 140, so the pages he needs to read is a minimum of 140, can he read more than 140? Could R be more than 140? Yeah. Could R be equal to 140? He needs to read a minimum of 140. Would 140 pages be enough? Yeah, it could be equal to. Could he read 139 pages? No, that wouldn't be enough. So R must be greater than 140, not less than, right? But it can also be equal to 140. But not just 140 pages, right? Because it says 140 pages, but he has 7 days to do it. So if we wanted to spread that out, how would we do that? He doesn't want to read 140 pages all in one day. He wants to read it over a period of 7 days. How would we do that? Well, we could split that up so that he reads the same amount each day. And what would splitting it up be? It would be division, right? So we could divide it out evenly over those 7 days. So we can simplify this. We can do R is greater than or equal to 140 divided by 7. 140 divided by 7 is actually pretty simple. We would do 7 cannot go into 1, but it can go into 14 twice. 2 times 7 is 14. If we subtract that, we get 0. We bring down another 0, and we still need a number to go up here. So 7 goes into 0 0 times. So that means he would have to do at least 20 pages a day, but he could do greater than that, right? Well, let's take a look at what a graph would look like. Remember, we want to put 3 numbers, and we want to put ours in the middle of that. So if the number of pages he reads is 20, 20 could be the number of pages he reads. So I'm going to color in that dot because I want people to know that that is a possible solution. So over here is going to be 21, and over here is going to be 19. My question is, what direction do we need to go? Well, we know that our arrow needs to go this direction. He must read at least 20, but he could read more, right? Excellent. Now let's have you try it on your own.